All right, ladies and gentlemen, so this is quiz number 4. Quiz number 4, the module number 4, or the chapter number 4 walkthrough, and we're going to go ahead and get started with the questions 4.2, A through E, C, D, E, and you're given a height of adults. Researchers studying anthropometry collected body girth measurements and skeletal diameter measurements, as well as age, weight, height, and gender for 507 in equals 507. I don't know if that's useful, but we'll see. Physically active individuals. The histogram below shows the sample distribution of heights in centimeters. Okay, number A, what is the point estimate for the average height of active individuals? And so it's right there, mean 171.1, right? Mean 171.1, right? The average height of active individuals is right there. What is the point estimate for the standard deviation of the heights of active individuals? What about the IQR? So standard deviation and IQR. Okay, so let's see here. How do we calculate a standard deviation? Oh, look, it's right there, 9.4. It's written for you. This is all about asking you how to read the table, right? The IQR 177.8 minus 163.8, which is equals to 14. Okay. If a person who is 180 centimeters tall, considered unusually tall. Okay, 180 centimeters, and a person who is 155, unusually short. Okay. All right. So let's see. So let's do the Z-score. Z of somebody who is 180 is equal to 180 minus 171.1 over 9.4. And this is 0.94. So if I were to draw that out, I would have 0 here and 0.94 right here. And is this more than 2 standard deviations? No. So that's within 2 standard deviations within 95% of the time that I would expect it to happen. So that's good. 155, we do the same. 155 minus 171.1. I already know it's going to be to the left, right? Because the numerator is negative. And that is giving me minus 1.71. So it's over here. 1.71. And minus. And so it's not beyond the negative 2. So we're good. So neither of them are unusually tall or unusually short. And the reasoning is because they're both within 2 standard deviations, and 95% of my values will be within 2 standard deviations. Okay? D, the researchers take another random sample of physically active individuals. Would you expect the mean and the standard deviation of this new sample to be the ones given above? Yes. I would expect them to be not the exact ones. So the answer is no because of sampling variation, but they're going to be pretty close. The mean of this new sample is going to be somewhere in here, and then so the curve is going to look a little bit different, but it's going to be somewhere in there. So the answer is no. I mean, you're going to have sampling variation, but it's going to be pretty close. And then the sample means obtained are point estimates of the mean height for all active individuals if the sample of individuals is equivalent to a simple random sample. One measure is used to quantify the variability of such an estimate. So that answer is the standard error. And the standard error is equals to the standard deviation over square root of n. And this is where this comes into play, that the bigger or smaller the sample is going to affect standard error. And so that is what you do. So in this case, it would be 9.4 over square root of 507. And it is 0.417, which is a little bit different, right, than your standard deviation because it's accounting for the size, for the sample size. Okay, so that is 4.2. So for 4.8, you're given an age at first marriage. You're given a histogram there, and you were told that you have an N of 5, 5, 3, 4. You're told that you have a mean of 23.44, and you're told that you have a standard deviation of 4.72, right? You have everything you need to construct your confidence interval. You got to make sure that there's independence, that because one woman marries early, another one might not, or that one woman marrying early doesn't influence another one. You assume that the data are normal. It's a little bit skewed, but it's only moderately skewed, not too bad. Okay, and so we have everything we need. It's to get our standard 95% confidence interval, z-score, right, times standard error of that mean. And so this is 23.44 plus or minus 1.96 multiplied by 4.72 divided by square root of 5534. And you do the math and you get 23.32 to 23.56. And this is your 95% confidence interval. This number here in red is your margin of error. Okay? All right. 4.12. I'm not gonna read you the whole thing, but just know that the null hypothesis for A is, actually we use colon here, is that the mu is equal to 1100. The current average calorie intake is 1100. The alternative hypothesis is that mu does not equal 1100. This is a two-sided test. Okay, when we have inequality here, two-sided. If our alternative was something like the mu is actually less than 1100, then it would be one-sided. And for B, our null is mu is equal to 462. Current average verbal reasoning score is 462. Our alternative is that the mu is not equal to 462. And again, it's two-sided. Okay. All right. 4.14, we are told that the mu is x bar equals 23.44 years, and the alternative is x bar greater than 23.44, and the social scientist believes that this value has increased, but she would also be interested if she found a decrease. Okay? She believes that it has increased, also would like to know if there's a decrease. Well, first of all, what is wrong here is that this should not be x bar, it should be mu for these two. And for this, it should be not equal, because this person is not interested in just in decrease, but also in increase, so it's not equal. Okay? 4.22, a food safety inspector is called upon to investigate a restaurant with few customer reports of poor sanitation practices. The food safety inspector uses a hypothesis testing framework to evaluate whether the regulations are not being met. If he decides that the restaurant is in gross violation, its license to serve food will be revoked. Write the hypothesis in words, okay? And full sentences. I love full sentences. I always try to get my students to tell me things in full sentences, okay? For the null hypothesis, the restaurant meets food safety and sanitation regulations. The restaurant meets food safety and sanitation regs. And the alternative is the restaurant does not meet food safety and sanitation regs. Okay? What is a type 1 error in this context? Remember, type 1 error is to reject the null when in fact it is true. the type 1 error would be to say that the restaurant does not meet the food safety when in fact it does. Question C, what is a type 2 error? And then in that one would be that the food safety inspector concludes that the restaurant does meet food safety and sanitation regulations when in fact it does not. D, which error is more problematic for the restaurant owner? Is more problematic if they get shut down and in fact they are meeting the regulations, so a type 1 error. Which error is more problematic for the diners, so the people eating? Well, more problematic for them is if it's not meeting safety regulations, but the inspector says that they are, so type 2 error, because they would be eating something that's not safe when it's been deemed safe. And last one, as a diner, would you prefer that the food safety inspector requires strong evidence or very strong evidence of health concerns before revoking the restaurant? That's up to you guys, however you want to tell me. If you're okay, I have been surprised at what people are willing to eat. So, you might want strong evidence as an indication of prefer strong evidence as an indication of any evidence that there might be some issue there. So, it's up to you. It's F is optional. You tell me. I want to see your answers. And the last one, 4.24, determine if the following statements are true or false. Explain your reasoning. If false, tell me how they should be corrected. Okay? So A, if a given value, for example, a null hypothesis value of a parameter is within 95% confidence interval, it would also be within the 99. Yeah, that's true. Why? Because we know that the 95% confidence interval is within 2 standard deviations of the, right? 2 minus 2, but then the 99 is within 3, right? So of course the 95 is going to be within the 99. B, decreasing the significance level of alpha will increase the probability of making a type 1 error. That is false. The significance level is the probability of the type 1 error. Okay, so if you decrease the significance level, then you're actually decreasing the probability of making a type 1 error, not increasing it. C, suppose the null hypothesis is mu is equals to 5, and we fail to reject the null hypothesis. Under this scenario, the true population mean is 5. Nope, that is false. Okay, if our null hypothesis is that the mean is equal to 5, and we fail to reject this, it only means that there wasn't enough sufficient evidence to reject it, not that it has been confirmed. Okay, and that's why we say we fail to reject the null. We do not say accept the null. We never say that. We just fail to reject it. D, if the alternative hypothesis is true, then the probability of making a type 2 error and the power of a test add up to 1. True. If the alternative hypothesis is true, then the probability of making a type 2 error and the power of a test add up to 1. And remember that table. Type 1, type 2, and then the null, the true null, and what we went with, reject, fail to reject the null. So if it's the null hypothesis is true and we reject it, we're making a type 1 error. But if we fail to reject it, we're okay. And if the alternative hypothesis is true, and we reject the null, and we go with the hypothesis, we're good. But if we fail to reject the null, when in fact the other one was true, type A, and you guys can see where power lies in there. And the last one, with large sample sizes, even small differences between the null value and the true value of the parameter, a difference often called the effect size, will be identified as statistically significant. This is true. So remember what I said, with if you have a small sample size and a big one, you might not be able to detect it. But if you have huge samples, you might have overlap But if you have huge samples and they are different, even the smallest difference can be identified. So the larger your sample, the more likely you are to identify something as statistically significant, because you're going to detect those small differences between the null value and the true value. And that's why it's true. And that's it. That's quiz number 4. As always, if you have any questions, comments, or concerns, discussion forum, send me an email. Let's talk. You know how to get a hold of me. The midterm is beginning. Make sure you go over all your notes. Open note, open book, open internet. Write all your answers in full sentences. No need to show me the work. If you want to, that's good. No need to show me the code. If you want to, that's okay. But in a couple of questions, you will need to show me your histograms and your scatter plots. So take a screenshot and put it on there. All right, that's it. Thank you, everybody.